boys and girls, welcome to video lesson 5-3, our lesson on the graphs and transformations of radical functions. First thing you ought to ask yourself, what is a parent function? What is a parent function? The mom and the dad. Just kidding. A parent function. A parent function is your basic function. Like for example, if I have a parent function of a line, it's going to be y equals x. That is our parent function of a line, and of course, a parent function of a line looks like that. Once I throw in an m and a b, we know that's a linear function, but now our graph has turned around depending upon the values of our m and b. So one parent function you already know about is the parent function of an absolute value function. Y equals absolute value x. Our parent function of an absolute value function, of course, is this v. This v right here, whose vertex is at the origin. Now with this parent function, y equals absolute value x, I can throw some other stuff in. Y equals a times absolute value x minus h plus k. So we now know this is not the parent function of the absolute value function. That is an absolute value function with the transformations a, h, and k, which we learned about way back in Unit 1. If I look at this guy, my parent function is the blue one right here, y equals absolute value of x, an absolute value function with transformations. I have an a of -2, which means my v got turned upside down because it's negative, and it got taller, it got stretched by a factor of 2. That's why it looks skinnier, but it's actually taller, it got stretched by a factor of 2. I have an h of -3. Remember that positive 3 makes it look like it's negative. It's -3. Move 3 places to the left. And I have a k of +1, which means my graph moved up 1. So here is a parent function of a square root function or a radical function. It's a square root function. Y equals square root of x. This is our parent function of a square root function. Go ahead and for a minute, if x is 0, 1, 2, 3, 4, or -1, you guys complete this chart real quick. Complete this chart, and I shall be right back. BRB. Okay, when we plug in our x values into our function here, if I plug in 0, y equals the square root of 0. Well, the square root of 0 is 0. If x is 1, the square root of 1 is 1. Y is 1. If x is 2, y is equal to the square root of 2, which is approximately 1.4. If x is 3, y is the square root of 3, which is approximately 1.7. If x is 4, of course, y is the square root of 4, which of course is +2. And, whoa! What happens when x is -1? Well, when you throw -1 into the radical, the square root of -1 is not real. Of course, we know it's I. It's the imaginary number I. But we're just going to leave that as blank. You cannot have a real answer for the square root of -1. So let's go ahead and plot these points real quick. We'll do that in red. When x is 0, y is 0. That's right here. When x is 1, y is 1. That's right here. When x is 2, y is 1.4. That's right about there. The next one is 1.7. The next one is 2. Sorry, this is working out the way it is. This graph is going to look something like that. There is our parent function of y equals the square root of x. Notice now that the domain, the x values of this graph is only when x is 0 or positive. There is no graph, there is no function when x is negative. So the domain, actually, I can write this down, the domain is x is greater than or equal to 0. And the range, let's just look at the graph now. Let me get my pointer back. The graph is only when y is greater than 0, and we know that by definition a radical is always positive, so y will always be positive here. So again, my range is going to be very similar to my domain, and that my range is going to equal y is greater than or equal to 0. In fact, when you just look at the graph, x, there's only a graph when x is greater than or equal to 0, and there's only a graph for when y is greater than or equal to 0. So a radical function has a limited domain and range. So transformations of radical functions, and what we're going to talk about the b, though we're not going to do this year. You'll use the b next year in pre-calc, okay? But the a, the h, and the k, and the b all work the same ways as they did in our other transformations. A is our vertical stretch. If a is negative, it's a reflection. Just so you know, b for next year is going to be the horizontal compression. If b is negative, it's a reflection over the y-axis, so it's a horizontal reflection. H, we know, just like before, is our horizontal shift, and our k is the vertical shift. It moves things up and down. H comma k is going to be our critical point. And when I say the critical point, what I'm talking about is in a radical function that looks like this. Right here, our critical point is going to be right here in green, where the graph begins and ends. So we're looking at this function right here, y equals 2 times the square root of x minus 3. Let's just look at this for a minute. We know that our a is 2. B in this case is 1, and right now we're going to always do b's of 1. We're not going to worry about b this year. We'll do that next year. H is positive 3. Remember, h looks opposite of what it is, and our k in this sense, there's a plus 0 here outside. H goes inside the radical, k is outside of the radical. K is 0. Okay? I'll do this in red, our parent function of a square root function, of course, looks something like that. Okay? What's going to happen now? Well, the fact that our a is 2 means it's going to be stretched out by a factor of 2. It's twice as tall. And it's going to move 3 places to the right. So my final picture, I'll do that in yellow, is going to be 3 places to the right. And it's stretched by a factor of 2. So it looks something like that in yellow. Notice now that our domain, x, has got to be greater than or equal to 3. And y is still greater than or equal to 0. Okay, if you look at the equation, if I tried to throw in an x that's smaller than 3, I'm going to end up like, for example, if x were positive 1 minus 3 is negative 2. Well, I cannot take the square root of a negative number in the real number system, so there is no graph anything to the left of negative 3. Okay, you guys look at this one for a minute. Write down the a, the b, the h, and the k. I shall be right back. Okay, you should have found that a is negative 1, so that's right here. Our a is negative 1. My b is 1. It's the number in front of the x, but b right now will always be 1. There it is, 1. H is negative 2. The number inside the radical with the x is x plus 2, which means it's x minus 2, so h is negative 2. And our k, of course, is outside the radical, negative 3. Because I have an h of negative 2 and a k of negative 3, that means that my critical point, let me get my marker here, my critical point is going to go to the left 2 and down 3. So my critical point is right here at negative 2 comma 3. And then it's going to be a square root curve, that square root curve, but this time because my a was negative 1, it's going to be upside down. So it's going to look something like that. Notice now my domain is going to be x is greater than or equal to negative 2. And my range is y is less than or equal to negative 3. As we look at our graph, x has got to be greater than negative 2. There is no graph to the left of negative 2. And my y is less than or equal to negative 3. Notice that there is no graph when y is greater than negative 3. Alrighty, you guys try this one on your own. Fill in the A, B, the H, and the K. Go ahead and draw your graph. I'm going to go for a quick little lap. I'll be right back. Okay, you should have found that A is -2, negatory 2, right there. B is 1, hey, B is 1, there's a 1. H is -4, -4 for H. Remember, x minus -4, it's x minus H inside my radical. So my H is negatory 4, and K, my vertical climb, is +1. Okay, K is 1. So now here's our parent function, right? Here's our parent radical function. What happens to this graph? Well, my critical point goes to the left 4 and up 1. So my critical point is right here at -4, 1. It's like my vertex when I'm doing an absolute value or a quadratic function. My critical point goes left 4 and up 1. And then it's stretched. It's stretched by a factor of 2. So notice this purple graph is twice as tall. It's stretched vertically by a factor of 2. It's turned upside down because it's negative, and it's stretched by a factor of 2. And here's my graph. My domain is x is greater than or equal to -4. X has got to be greater than or equal to -4. And y is less than or equal to 1. Okay, let's look at this guy right here. Y equals the third root of x minus 2 plus 1. Before we even do this, okay, let's write down the A, B, the H, and the K. A is, you guys are telling me, 1. Very good. B, of course, is also 1 right now. H is +2. K is +1. I hope you all got that as quickly as I did looking at that graph. Very good. Now, let's just talk about y equals the parent function for a third root function. Y equals third root of x. That parent function is going to look like this, and I'll do this in blue. It's going to be similar to the square root function on the positive side, but there's also a third power function. Also includes the negative side, because you can take the third root of both a positive and a negative number, and we'll talk more about this in class, but there is our parent function for a third power function. Okay? Now, what happens here? The A is 1, so there is no stretch or reflection. A is 1. B is also 1. Good. H is 2, which means now my critical point is going to go right to, and K is 1. So my critical point right here is going to go right to and up 1. So let me get my marker back, and we'll do this in red. My critical point is now here, and this graph is going to go to the right the same way, and then it's going to do a little S-curve and go like that, and it basically looks like a third power function on its side, and we'll talk about that later when we get to inverses. But there is our final graph. Notice now that the domain is all real numbers, -infinity to positive infinity. X can be anything, and y also will continue to get big forever. As this moves to the right, it'll continue to move up. So y can be any number in the positive and the same thing in the negative. This will continue to fall down as we move to the left. So the range is also all real numbers. Hey folks, that's it. Have a great day, and we shall talk to you soon.